Alright, let's get the SL stuff over with. This should be a quick video because like half the questions I've covered because they're also in the HL paper. So yeah, I don't know, I'll just get into it. This is paper 1. This is an SL question that didn't appear, but we have a box and whisker plot of 80 golfers. Sure. Find the IQR, so interquartile range. For those that don't know, but I guess if you're writing a paper at this point you should. This is the min. This is the first quartile. This is the median. Oh my god. This is Q3. And then this is the max. My hand is like not well right now, so my writing's gonna be shaky because I just like worked out essentially. Anyways, okay, the interquartile range is simple. This is Q3 minus Q1. So in this case, that's 74 minus 68, which is whatever this is, 6. Okay, and then find the number of golfers that scored between 70 and 74. So 70 is right here. 70 is your median. 74 is Q3. And then these are called quartiles for a reason. This is literally 25% of your data. 25% of your golfers scored between 70 and 74. There are 80 golfers, so basically 25% of 80 is whatever this is, 20. Oh my god, I can't write right now. Anyways, okay, easy enough. 4 marks. Question 2 is this log question, so this was covered in the HL one, somewhere, paper 1. Yeah, this was question 1 in the HL, so go watch that video. This is question 3, which is also in the HL. I believe that one is question 2 in the HL, right here. And then question 4, I think, is new. So it looks like we're gonna do some trig identities. I need some space. Okay, you show this is gonna be equal to this. Okay, so we're gonna use some trig identities. It's not really a good way to like tell you guys of how to do this. You just kind of got to see it. But essentially, this is a difference of squares. So this is essentially, you know, like a squared minus b squared, where a is cosine squared x. That's why when we square the square, it becomes a 4. And then b is your sine squared x. So this is gonna factor into sine squared x. Oh my god, my writing's so bad right now. Cosine squared x. Right, this is a plus b, a minus b. And then each one of these is an identity. This one is 1. And then this right here is literally in your formula booklet, cosine 2x. Oh my god. And then there you go, we're done. And then hence, we are gonna find the integral of this thing. And then I said this in the previous videos, and I'll say it in every video, hence means that we're going to use what they've told you in part A. So whether or not you've actually been able to demonstrate this, you're still allowed to use it. So if you see this, we can turn it into cosine 2x. And then that's why they say hence. Hence means use this to do this question. And then that's kind of nice, right? So that even if you don't get the first part, you can still use it and do the second part. So we take the integral, and then this thing, we're gonna change it to cosine 2x because of part A. And then we take the integral of this. This needs a little bit of a u substitution if it helps you see it. Oh my god, I'm so embarrassed that my writing is in shambles right now. Okay. So this, we're gonna do a little u substitution. This is gonna be, what, half cosine, oops, no sine. And then we'll undo the u substitution. And then don't forget your constant. There you go. Okay, question 5 is also here as question 4 in the HL video, HL paper. Question 6 is also in the HL paper, right here as question 5. And then we've made it to the long answer. Let's see, what is this? The gardener wants to build a rope fence. Total area needs to be 60, okay? 8 identical rectangle areas, x by y. Okay. Find an expression for y in terms of x. Okay, so that's easy enough. We know that the total area needs to be 60. We know that there's 8 identical rectangles, so then x times y is the area of one rectangle, and we have 8 of them. So 8 times x times y should be 60, and then they want to solve this for y, or write an expression in terms of y, or for y in terms of x. So we isolate this. So we get what, 60 over 8x, and then 60 over 8 can probably reduce to something. 60 is divisible by 4, no? Is it divisible by 8? No, it's not. 2x, and then what, 25? 15? There you go. So 15 over 2x. Okay. Then we need to show that the total length of the rope required is this thing. Okay, so the total length of the rope, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 y's. And then we are going to get rid of the y's using part A. We know what y's are in terms of x, so we're going to just do a little substitution here, right? Y's we can replace with this thing. So then we get 12x plus 10 times 15 over 2y. And then we can simplify this. 10 divided by 2 is 5. And then 5 times 15 is probably the 75 right here. And then this turns into this. Done. Okay. Next up, find an expression for dt dx. So we're going to take the derivative of this. And then again, they're nice because if you didn't know how to get t from part B, you can still take the derivative of t. Okay. So dt dx, take the derivative, 12x becomes 12, and then this thing, 75 over x, becomes negative 75 over x squared. Simple derivative. You can use your derivative rules. And then let me just double check that I did this properly. I think I did. Sure. Okay. So when x is a certain value, this derivative is equal to 0. Find out what that value is. Okay. So we make our derivative equal to 0. And then I guess we can replace x with k. Solve for k. So let's see. Move this thing to the left side. $75k squared equals 12. Okay, solving for k. Switch the k squared and the 12. And then we're going to square root this. Now, we are going to briefly consider plus or minus, as you always should, when we take the square root. And then 75 over 12. Please tell me that this is something nice. So 75 over 12 reduces to 25 over 4. So k is going to be 5 over 2. Now, we do need to consider plus or minus for a brief second, and then you need to think about the context of the question. K is a value of x. X is a length of rope, so we don't need to consider the negative part anymore. So k is positive 5 over 2. Then find the value of... hence calculate the value of t when x is k. That's easy enough to do. We have our expression for t right here. So t is equal to 12k plus 75 over k. Right? Yeah. Okay, simplify. This is 6. So then this is 30. 75 divided by 5 is 15. 15 times 2 is 30. So t is 60. Sure, something like that. Okay, and then what else do they want? Find the value of y as well. So what did we say y was? Y was like 15 over x or something. 15 over 2x, okay. $15 over 2 over times 5 over 2. Okay, 2's cancel. 15 divided by 5 is 3. Okay, there you go. Are we done this question? I don't think so. Okay, find an expression for d squared of t over dx. Okay, second derivative. Okay, we have the first derivative. So just take the derivative again. What is the first derivative? Right here. Okay, so 12 goes away, and then this becomes something. 75 times 2, 150. Something like this. Yeah. Okay, take the negative 2 here, so it becomes positive. 150, 2 times 75, and then this becomes a cubed. Okay, and then hence justify whether t has a local minimum or a local maximum when x equals k. Okay. So there's a few ways that you can do this. You can actually physically calculate it. We're going to use the second derivative test. If the second derivative is positive, where we have a critical point, so the critical point is an x value where the first derivative is 0, then if the second derivative is positive, that means that it's like concave up, so your critical point is a minimum. And then if it's like if your second derivative is a negative, then that's concave up, so your critical point is a maximum. Okay. Now, what you can do is you can literally just plug in 5/2 and then calculate it. But of course, look at this equation here, right? This 150 is positive. K is positive. That means that k cubed is positive. So positive number divided by a positive number, this is going to be positive. The whole thing. That means that we're concave up, so we have a minimum. So yeah, this is a minimum value of t. In other words, if you want exactly 60 square meters of area, this configuration of x and y gives you the 60 meters squared of area using the least amount of rope. Okay, and then question 8, this is just the beginning of it, but that is in HL as question 10. And then we're already at the last question. Granted, you're like, I skipped half of this, so yeah, let's see. First, we solve a quadratic. Easy peasy. We're gonna factor it. Looks pretty easy to be factored. I think it's 5 plus x 1 minus x equals 0. Yeah, it just takes me like half a second more if like it's in ascending order. But I believe this looks good. Okay, then we solve this, so x can be either 1, because 1 minus 1 is 0, or x can be -5, because 5 plus -5 is also 0. Hence, we need to find the values such that this thing is greater than 0. Okay. So this is a quadratic inequality. What we just did in part A is we essentially found the values of x that give you an x-intercept when you graph them, right? These are values of x. When you plug it in, your y value is going to be 0. So very quickly, you can sketch this out to see what it looks like. So we have an x-intercept here at -5. We have an x-intercept here at positive 1. And then our leading coefficient is a negative 1 in front of the x squared. So this also tells us the direction of the opening of our parabola. So this opens down. So, woo, like that. Okay, then this is saying which values of x is our parabola, our graph, above 0, greater than 0. It's talking about the y values, right? This whole thing is the y values. Y. And then because we know what the graph looks like, we know exactly which values of x produce a y value greater than 0. All of these are greater than 0. Right? Our y values, our y values. So this is x between -5 and 1. So we can just write that down. And then let's see, what do we do? And then we take this and then we take the log of it. And then here's our graph. Looks like this. Okay. The graph of f has two vertical asymptotes at a and b. Write down the value of a and b. Okay. So you need to know properties of what a log function are. So there's a few rules about log. First off, oh, that's a k as the base. You know what? Okay, let me change that to a b. Okay, first thing you need to know about log. X has to be greater than 0. Actually, let's do b first. Okay, your base has to be greater than 1. This has to do with understanding what a log is. A log essentially means that y is the exponent, x is the result of taking b to the power of y, right? We can always change this into an exponential expression. Okay, it won't let me change colors. So b to the power of y equals x. Okay. Now, this means, you know, there's some restrictions about b if we're interested in exploring what a log graph or function does or is. It has to be greater than 1. It cannot be equal to 1, because that means that you're just taking 1 to the power of something. And we know that x is always going to be 1, because your base is 1. So we don't need to really consider when the base is 1. Secondly, b, our base, oh, this is a little confusing because this b is not the same as this b. Right now I'm talking about b for the base. B can't be negative. I know a base can be negative, but what that does is it doesn't lead to a continuous graph, because then, like, let's say that b was a negative number, like -1. Then, you know, we can just take even whole number integer powers. This is going to be +1. This is going to be -1. This is going to be +1. So if you were trying to make a graph of this, like, it would be jumping back and forth. And that's not even to mention what happens when your x value, your exponent, is a fraction or a decimal number, an irrational number. And this just is not, it's not nice. So we ignore it. And then that means, right, our base is just greater than 1. Okay, so if our base is always positive, then that also means that x, our result of taking this exponent of y, is always going to be a positive number. Not only that, but it's also obviously bigger than 0, because the base is bigger than 1. So hopefully that helps you understand a log function a little bit more, right? This is the result of taking the exponent. It cannot be 0. What that means is that here are two places where your log is 0. These are vertical asymptotes. Alright, when is our log 0? It is when this... Oops. It is when the inside of our log is 0. This is right here. We found out where this thing is 0 in part A, which is at -5 and 1. So A is -5, B is +1. Okay. Then find the exact values of x such that this function is equal to 0, so that's easy enough to do. Right, so they're saying that log k of 5 minus 4x minus x squared is equal to 0. Usually we solve a log equation by changing it into exponential form. So this is saying that k to the power 0 is equal to 5 minus 4x minus x squared. K to the power 0 is 1. Okay, and then we can just solve this. So everything goes to the left side. Left side so that my x squared is positive. Okay, and then we try to solve this. I think if I did this all correctly, this is not factorable, which means we need to put this into quadratic equation. So x equals to negative b plus or minus square root of b squared, so 16 minus 4 times a, which is 1, times c, which is negative 4, so 16 plus 16, divided by 2a, so 2. Okay, negative 4 plus or minus the root of 32 over 2, and then, let's see, simplify the root of 32. Okay, the root of 32 is like 16 times, oh yeah, oops, 16 times 2, okay. (16 times 2, the root of 16 is 4, so this is 4 root 2, and then we can divide our terms by 2. I can't change my colors right now. So this becomes negative 2, and then this becomes negative 2. And then the plus or minus and the negative doesn't really matter. So your exact values are -2 plus or minus 2√2. And then let's see, the graph of f has a minimum value of 2, find, or maximum value of 2, find the value of k. So this is a maximum value. It's worth 6 marks, by the way. So I don't think it's enough justification to say that it is the value in between A and B. It probably will end up being that way because a parabola is symmetric. And then this, if you take the log of that, it still is symmetric. So how would we do this? Because it's worth 6 marks. It's a maximum value. What could we do? Because it's a maximum, okay, let's just do calculus. Is that the best way? I don't really want to do calculus. Okay, I'll show you 2 ways. So currently, what we're doing is we are taking these y values from here to here, and then we are gonna place them into a log, which results in a log graph that we saw earlier, right? And then they're saying that this maximum is 2. Okay. So, logically speaking, right, the larger the y value is, means the larger the y value on the log graph is. Right? If you're having a little trouble wrapping yourself around this, think of this as in terms of exponential form. Right? This is the largest when your exponent y is the largest. Okay? Or vice versa. That means that your exponent y is the largest when this is the largest. This is the largest here. So what I'm trying to do is I'm just trying to find the x value. Oh, this should be a 1. So this is when we have the largest input into our log, right here. This means that we would have the largest y value. And then y is what we're considering the maximum. So this number is what? -5 plus 1 divided by 2, -2. -2 here. So when x is -2, we have a maximum value for our parabola. So this means that this value here is 5 minus 4 times -2 minus -2 squared. Okay, what the heck is this? 5 plus 8 minus 4, so 9? Okay, so this is 9. That means that k to the power of 2, because that's our y value for this one, is 9. So k is 3. Good. That's probably the easiest way to do it. Right, that's why it's 6 marks, because you're not finding the x value that gives you a maximum, you're trying to find k. The x value is -2, but the k value is 3. Could you use calculus? Probably. You can probably take the derivative of this, which would be really nasty. I don't think you can as an SL student, so yeah, never mind. There's only this way. Let's just say that there's only this way. And then there you go. That is SL paper 1. Honestly, very easy paper. From these questions alone. If you throw in the other questions from the HL, it's like slightly below medium. I think the harder questions... This question is difficult if you didn't spend too much time on log graphs. This question that I skipped was a little tricky. And then the rest was straightforward. Yeah. Like, somewhere between easy and medium. Okay, thank you for watching. I'll do paper 2 at some point. Bye-bye.